Hi everybody, this is Joe/FoozleCC, and today I'm going to be giving an introduction to procedural generation inside of the Construct 3 video game engine. It's a deep topic, but you have to start somewhere, and that's what we're going to cover today. Okay, so procedural generation inside of Construct 3. Thankfully, there's already a couple of great projects built right into the editor that we can reference and start our learning from. So with that said, let's go ahead and dive into those. The first thing that we're going to want to do is you come over here and you start typing in procedural. You'll see this procedural terrain generation. That's the first project that we're going to be leveraging to understand how this works inside of Construct 3. The second one, to help us understand what's kind of going on in the background, is you want to type in this noise texture project. And we're going to look at both of these to gain an understanding of how to leverage noise textures. Specifically, we're going to be utilizing Perlin Noise to help build out worlds using procedural generation. So let's go to the first project, which I've already loaded up, called the Procedural Terrain Generator generation. Inside of the layout, you can see here that you've just got this simple platformer player who's kind of constrained to this player base, and the player base has this platform behavior on it. And what's going to end up happening is it's going to dynamically generate the world that this guy's going to run across. So let's go ahead and hit play. Okay, so as you can see here, I've got this cool character. He can do jump, double jump, and all this is being dynamically created. And what's really cool about this is that it's not some massive layout that we're creating this in. Remember, if you look at this layout screen, I mean, the size of the layout is only 2400 by 1600. What's actually happening is we are constantly moving the world so that we can continue to generate these chunks, which we'll talk about, as we move around and reload those and shift the player so that we always kind of stay inside the same bubble of our layout. And that's one of the cool concepts about this that we have to make sure we understand, because now that we are using procedural generation, this concept of moving our world as we travel combined with procedural generation allows for those kind of infinitely explorable worlds like Minecraft, etc. So let's go on back to the event sheet and see how this is being done. Okay, so inside the event sheet, there's some things that we have to keep track of. The first is our terrain tile map and tiles. So this is saying I have 40 tiles high and I'm 60 tiles wide. And you guys can set this to whatever you really want it to be inside your own games. The next concept is this size of chunks. The world height needs to be some multiplier of your chunks. So if you have 15 here in terms of width, 60 is a multiplier of your width of 15. Same with chunk height. 10 times 4 is equal to 40. So you want to make sure that you're doing that. So the chunk sizes are 10 high and 15 wide. And what this is going to allow us to do is to work on those chunks as they're needed as we explore our world. So we aren't generating the entire world each time we move. We're really just focusing on saving, loading, or generating as needed those chunks. The next thing that we need to do is keep track of where we are in terms of the world, right? So even though we're moving all around and we're kind of staying inside this bubble, we need to keep track of the virtual offsets of X and Y that our player has moved so it knows where we are. And then last, we need to provide what the grid size is in terms of pixels. So if you're working with a tile set that's 64 by 64, you would change this to 64. All right, coming into our setup here, the very first thing that we're going to do is we're going to utilize this advanced random plugin. And we're going to pause here and dive into what that is for a moment. Inside of the manual, you can do a nice read on what this is meant to be. At its heart, it's a pseudo random number generator, or PRNG. And what that means is that I can get random values out of it, but it's pseudo because I can provide it a seed and get the same value back each time if I use the same seed. And that can be incredibly useful in building worlds. And it allows you to create levels that can be replayed, etc. One of the most common uses of this is to generate something called Perlin Noise. And that's what we're going to use inside of our game. But to help us understand and visualize this, we're now going to jump over to that noise texture game or project template that we talked about at the beginning of the video. Inside of here, if you come in, you'll notice that it's a really simple screen. But if you come into the event sheet, what we're going to basically do is we're going to use this to help visualize what this advanced random plugin is allowing us to do. So let's give it a play. Okay, so the very first one that comes up is Perlin Noise, and with an octave of 1, which you can increase. And what this does is, as you can see, it kind of makes it more detailed, right? As you increase your octaves. For the purpose of the platformer, we're using an octave of 1. And when you look at this, it's a lot more organic looking than, let's just say, a typical random, which looks like ants having a snowball fight, right? It's just black, white, black, white, black, white. There's no organic look to this. The classic Perlin Noise gives us this kind of nice organic shape, and it's really useful in building out worlds because it kind of looks like what topography might look like on a map. So using these values, we can manipulate the 0 to 1 value that comes out based off of the X and Y that we feed it to get a more interesting looking level or map in our game. You will find that the magic and the trick is in how you either make use of multiple sources of noise or how you manipulate the value that you get back based off of other information to achieve the effect that you're hoping to inside of your games. Let's go back to the event sheet now that we have an idea of what this kind of looks like. In fact, let's give this a quick play. Now, you've seen that image. You can think about the platform that we're running across as really one of those like ridges that you saw, one of those black and white ridges that were kind of flowing through the Perlin Noise. But you'll also notice that somehow this is not looping back on itself like you saw on the map. And that's because it's utilizing some algorithm on the value to make use of achieving this platform behavior. So let's go back and see what they're doing. World squirreling. World squirreling is a really important topic to enable the infinite movement. So let's at least take a look here before we move on. What we're going to be doing is effectively looking at that player and seeing like, okay, am I moving outside of my box I'm supposed to stay in? And if I am, let's use this move world function. And that move world function is a combination of steps. I'm going to save the current world that by chunk. I'm going to save that into some data structure. I'm also going to set what my new offset is. So where will I be in the world now? But with my virtual offset X and offset Y. And then I'm going to load the world. And that will allow you to, okay, if I've already been here before, let's load back the same values that I already generated so it feels the same to the player. And if I haven't, let's generate additional tiles. And then I'm going to also shift my player back by the amount of offset so it looks seamless to the user in that it doesn't feel like they've all of a sudden just like jumped, right? And that's what keeps them in the center of your layout. Okay, let's keep going. Inside of this this function here, we'll start with save world. So save world, it simply loops through and it will save the chunks into using this save function, which come up here in chunk methods. And you pass in the current chunk you have. You also pass in this dictionary key, and that's going to let you know, like, well, I'm offset X and offset Y. This is what I'm going to name this chunk that you'll be able to use later if you're loading it. And I'm going to effectively write it to a JSON object and then push that into a dictionary. And that dictionary is what's really going to retain all of our game state. Okay, coming on down. After saving it, we're going to load it, right? And the load world makes use of both the load and generate functions. So if it has the information, let's load it. Otherwise, let's generate it. So if you come back up here now to load, it's looking for that dictionary key, if it exists, and it's going through and it's loading the data into the tile map, and it's setting the tile map value. Otherwise, it's going to generate it. And this is where you make use of the value coming from the advanced random plugin of the classic 2D / Perlin Noise. So let's look at this value right here. Set value to advanced random, that classic 2D, and it's plugging in kind of your position, the X and the Y on the image, and it's getting back a value. And it's basically a scale of the white and black. You're getting a 0 to 1. And what they're also doing is multiplying it by scale, which they've currently set to 1, and then also this density scale. And this is where they manipulate the value coming back to make it achieve that single top layer. And this density scale is effectively a clamp off of your Y position in your world, so that as you are going upward, which is a lower Y, it will eventually result in you multiplying this value by 0. And what you can see down here is they make use of that, and they say basically, okay, if I'm above 0.5, I'm going to have stone or ore. If I'm between 0.5 and 0.47, it's going to be like, I'm close to the top, so it's going to be dirt or maybe some grass. And if it's below 0.47, it's going to be air. There's going to be no tile. So because of this Y algorithm, it's causing this to be called as you go upward. So there's no tiles up above the player in that world. And this is one of those tricks that for whatever effect you're trying to achieve inside of your game, you're going to have to do something similar with that value to likely come up with the result you're interested in. If you come in here, they make use of a couple other tricks, and this is some of the things that you're going to have to think about. And they say, okay, if I am stone, maybe I give an additional random chance to be this iron or the gold or the gems. And they actually call another advanced random function, the cellular 2D. They make use of that combined with this Voronoi 2D to sample it and say, if I'm above 0.95, be diamond for a 5% chance, 15% chance gold, 80% iron. And you can do something similar to that. Otherwise, just call the normal, stone. And then they also have this thing for dirt or grass where it's like, hey, if it's air above you, change it to grass. Otherwise, it's dirt. It seems simple enough. And now we have an understanding of this is how this thing is working. That was the whole trick is, above a certain value of Y, or I guess as you go lower in Y, because as you go up, it's a lower Y. Multiply, your overall value coming back by a smaller and smaller number all the way to 0, and then do a check on if you're less than 0.5, make it air, or less than 0.47 in this case. And now we've created our game. All right, so now what we're going to do is we're actually going to make a quick modification of this game where we're going to sail around a whole bunch of randomly generated islands. So let's see how quickly we can do it. So I've already come in and created from the procedural generation template. The only change I've made is I've changed the player sprite to a boat. On the player base, I've disabled the platform and I've enabled 8 direction. And then I've also come in and I've also set it so that the player will rotate with the player base. So it looks like as I move my boat around, it's all changing direction. That's all I've done. So let's go ahead and make this into generating random islands and see how quickly we can do that using this as a foundation. So I'm going to take this terrain tile map and I'm actually going to change it from what they provided here to the pirate pack from Kenney. And you can see that there's some nice things. I'm just going to use some grass. So let's go ahead and close this. And one of the things you'll notice right away is that this isn't a 40 by 40 like the previous. It's a 64 by 64. So let's come over here and change this to 64 by 64. And similarly, you'll realize that our layout and our tile map size needs to change, or it should change. I like to keep it a multiple of my tile size. So instead of it being a multiple of 40, so this remember we had 60 tiles wild. Instead of 60 times 40, it's going to be 60 times 64, which is 3840. And then we're going to make it similarly 40 times 64, which is 2560. And we also are going to then come down to the tile map and change that size similarly. And now you can see we've got this setup of still 60 by 40, but now we're using 64 by 64. If we come into the event sheet, we're going to change our grid size to 64. And everything else is good to go. Now the next thing though I want to make sure I do is I'm going to change that algorithm, right? On the generate function, they're using this density scale. Let me go ahead and copy this and disable it. And I'm just going to make it equal to 1. And now all I'm doing is multiplying by 1 no matter where my X and Y position is. So I hope to achieve something much closer to that original image, which already kind of looks like islands or land masses. And let's give this a play. Oh, before I do that, let's change the tile map numbers that we're calling. So if you come down here and we look at, okay, 0.5, 0.47, you know, I'm not even going to make use of this dirt or grass. Let's toggle this. So it'll be empty if it's below 0.5 or equal to 0.5, and if it's above 0.5, we're going to set a value. And we'll say the default will be, let's make it this grass right here, 22. So let's set this equal to 22. And then we'll use 23, 38, and 39 as our slightly lower chance tiles. All right, let's give this a play. Okay, so let's see what's going on. It looks pretty similar, except for, oh, now it's okay, it's going a lot higher. Oh, and it's actually curving back on myself. But you know what? This doesn't seem like the right scale. So let's go and change the scale a little bit and see what we can do. Instead of using the scale of 1, let's kind of zoom in a little bit. Or better at zoom out. And look at it that way. So let's change that to 5 and see what comes up. Oh, I'm actually landlocked because I randomly spawned myself in the middle of the land. So let me disable the terrain tile map solid and give this a play, just so I can kind of go all around without having to worry about staying in the water. You can probably come up with another method for making sure you spawn in the right location. But look, now we've got this kind of cool map that, you know, apparently I can drive around on the grass. But you've got this something that looks a lot closer to water and land and islands. And this is really cool. And this is kind of that first step in procedural generation that most people start with. So give this a try, and you'll find, like, hey, this is really cool. And then there's going to be all these other things that you want to do. And you're just going to have to tinker and figure out what sort of algorithms that you can use and how you might make use of multiple random noise and, you know, Perlin Noise or some other type of method inside of the advanced random to create some really interesting worlds. Now, we didn't cover things like dungeon generation because that's almost its own field of procedural generation. There's a lot of other methods that people use for making, you know, hallways and rooms and already predefined room sizes. But I definitely encourage you to go over to the Reddit procedural generation, join it, you know, take a look at what people are creating. They're creating really cool art, and they're also creating like dungeon generators and terrain generators, both in 2D and 3D. And there's just some really cool stuff going on in this field, and you'll learn a ton just by seeing what other people are doing. But that very first step that you're making is typically going to be closer to that, hey, let's make a 2D map that looks somewhat like maybe some land and some water, and go from there. All right, everybody. So that was my very introductory level course on procedural generation inside of Construct 3. I hope that that was useful for you. If you enjoyed it, please consider giving me a thumbs up, a comment down below, or maybe even a subscribe if you haven't subscribed to my channel yet. It's free for you to do, and it makes a big difference for me, so I really appreciate it if you do. And with that said, have a good day, everybody, and good luck in your game dev journey.